An MCC acts as the COSPA Sarasat system's data router. Alert data are received by an MCC, either from its associated LUTs or from another MCC. This data is then distributed in accordance with procedures and arrangements for data exchange documented in the Data Distribution Plan, or the DDP. The DDP provides data distribution matrices which define required actions depending on the status of the data received by the MCC. The specifications for the matching and merging of alert data and the associated processing matrix are all contained in document COSPA Sarasat A.001. Alert data are received by an MCC either from its associated LUTs or from another MCC. The data is then forwarded to either an MCC or to search and rescue authorities when it contains new and useful information. The MCC will not send an alert message received from one MCC to another MCC if the new alert message contains redundant information. The alert data distribution process consists of a set of rules commonly used by MCCs for deciding whether data received for a particular 406 MHz beacon ID contains new information. These basic rules and the variety of position data available in 406 MHz alert messages create a large number of possible combinations, which need to be thoroughly assessed by the MCC to ensure the consistency of the alert data distribution process throughout the MCC network. In order to implement this data distribution process, new information, referred to as input or I, must be compared with the information already transmitted associated with the same beacon ID. The history of all data already transmitted must be preserved in a status word, SW. Similarly, the action or actions resulting from the process can be summarized in an action word, AW. The functional relationships between input, status word, and action word are summarized here, as you can see from this diagram. The possible combinations of position data which characterize an input, I, the current status, SW, status word, or the resulting action, AW, action word, of the process concerning a given beacon ID are identified here. These are called matrices. A matrix is a grid used to store or display data in a structured format, in this case for 406 MHz alerts, as you can see here. The possible position information contents of I, SW, and AW are summarized in the last column. We can note that SW5, SW6, and SW7 each mean that position has been confirmed. We can see that as we look back to the first graphic, the triangle presenting process. In order to process each input status combination to provide the possible output, action word, the corresponding SIT message numbers, and the appropriate recipients of this information, the MCC software generally uses a processing matrix. As a general rule, all input position data is compared to the last resolved position transmitted by the MCC, except for when additional encoded position data is received. As you can see here, table 410 and 411. These matrices define the processing done by the MCC, starting when the beacon ID is first detected. They then define what the MCC does when multiple unlocated and located alert from the same beacon ID are received. The processing matrices take into account all alerts received for the beacon ID, regardless of whether the information came from the LEOSAR, GEOSAR, or MEOSAR system. When more than one alert is received for the same beacon ID, these matrices define required actions for many cases, take into account the fact that the newly received alert may contain redundant information, may be located in a position different from all previously located alerts for this beacon ID, or may contain information useful for confirming the distressed position. For example, A first located alert for a specific beacon is forwarded to the relevant MCC in charge of the service area where the beacon is located, and is finally sent to the appropriate SPOC, search and rescue point of contact, as the first alert or initial alert received for this beacon ID. Depending on the location of the next alert received for this beacon, the MCC may generate a position confirmation message for the SPOC, or for another MCC if the position is located outside the local service area of the first MCC, if the new position matches a previous one already processed. The MCC might also generate a position conflict message if the position differs, or no outgoing message if the new alert is similar to a previous alert already processed and does not offer additional valuable information, such as a redundant alert. For the next alert received for this beacon at the MCC, it will compare all old data received for this beacon to the new position data received by performing position matching tests. The new position data in the input message is compared with all positions previously received for the same beacon ID, and these matching tests can lead to different results that are listed in these matrices. After position confirmation, the distribution of input alert data normally continues, and a different processing logic must be implemented, since the initial objective of increasing the position information content to obtain a confirmed position has already been achieved. Kospa Sarsa, we save lives.